there it is. Okay, so, yeah, all right. This one works. Cool. I don't think we have any sort of lapel mics. Okay. And then, if you're ready.
I am.
All right. All right, welcome everyone to day 2 of the conference. This is in track 4, and today, join me in giving a warm welcome to our first speaker, Torgin Mackinga, as he talks about future block MEV and proof of stake.
Hey, yeah, welcome everyone. Thank you very much for showing up so early in the morning. And yeah, I'm going to be talking about future block MEV and proof of stake. So first of all, kind of about me. I come from a security background, so I work at Chain Security, where I do smart contract audits. We work together with most of the big DeFi protocols, such as Maker, Curve, Compound, Aave. Yeah, and today I'm going to be talking not specifically about smart contract security, but more about how Ethereum works in general and kind of what the implications are from that, partially from a security perspective. So what I'm going to be talking about is future block MEV, which is a word that I totally made up, but I'm going to explain to you what I mean by that. So for that, first we have to understand block production in Ethereum. So block production has changed quite a lot over the last couple months. So Ethereum used to run on proof of work, right, until the merge happened. And in proof of work, basically every miner tried to mine every single block. And then if you got lucky, you were the miner that was producing the next block, but it was totally random and you couldn't predict it. And now in proof of stake, everything is a lot more structured than it used to be. And the block producers are actually determined in advance, deterministically. So the way it works in Ethereum is that you take the current block producer set and the Randau value, and based on that, you know who the future block producers are going to be. And these values can only change at most once per epoch, but usually they actually don't change 2 epochs in advance. And an epoch in Ethereum is 6 minutes. So what that means is that if you are a block producer or someone you know is a block producer, then you will know up to 12 minutes ahead of time when you will be creating a block in Ethereum. And of course, block production is very important, and the reason for that is MEV, right? So MEV is basically the value that can be derived from ordering the transactions within a block, which is what the block producer can do, and then also from inclusion or exclusion of any transactions. And so one specific type of thing that you can do with this future block MEV is an oracle manipulation. And usually and specifically the type of oracle manipulation that I'm going to be talking about today is for the Uniswap oracle. And this is something that I've researched quite a lot, initially in the proof of work setting and now in the proof of stake setting. And basically in proof of work, it was already kind of easy to manipulate if you did some specific things. But now in proof of stake, it's going to be a lot easier. So the way that so first of all, a price oracle, the idea of a price oracle is that it tells you what the price of an asset is. So if you have some lending protocol like Aave, let's say, what that'll allow you to do is you can put in some asset, let's say like ETH, and then you can borrow a different asset like USDC. But for that, the smart contract first needs to know how much an ETH is worth, right? Because if you put in 1 ETH and it's worth $1,000, then it might let you borrow like $800 of USDC. And then you'll have an over-collateralized loan, which means there's little risk to the borrowers, to the lenders from your borrow. But if instead the contract thought that the ETH is worth $2,000, then all of a sudden it'll let you borrow more against that collateral, and you might actually be allowed to borrow more than what the collateral is worth. And then at that point, you can just never pay back your loan, and you'll be stealing from the lending protocol. And so there's basically 2 types of oracles. One are the off-chain oracles, and the other are the on-chain oracles. So the off-chain oracles are things like Chainlink, where you take the price from some price source that's off-chain, and then you have some trusted party that posts that price on-chain, and then you just kind of believe it, right? Which is not great because we're trying to build kind of trustless systems here, and if you, at the core of your mechanism, you have a trusted party, that's not really what you want. So the alternative to that are on-chain oracles, and there, what you try to do is you take data that's already on-chain, and then you just work with that. And so the most popular, or at least it used to be popular, it's not so much now because people know that it's manipulatable, but the most popular one is the Uniswap oracle. And so what that does is that it takes the price of a Uniswap market, which is on-chain, of course, and then you just take an average of that price over some time, like let's say the 30 minutes, last 30 minutes of Uniswap prices, and you take that as your price oracle. And the idea is that that oracle should be pretty close to the overall market price, because if the Uniswap market had a different price than the off-chain markets or like any other markets, then there would be an arbitrage opportunity, right? If you can buy it for cheaper on Uniswap and then sell it back on Binance or something, you can just make a risk-free profit by taking the correct sides on each market. And so the first version of the Uniswap oracle, it just took the current price at whatever moment you asked it to give you the price, and that's really bad. Because what you can do is you can take a flash loan and you just buy a bunch of the asset on Uniswap, and then you check the oracle and it says, oh yeah, it's super expensive, and then you sell it back and you bring the price back to where it was, and you have basically no cost, and you can manipulate the oracle. So what they changed in Uniswap v2 is that instead of giving you the price at any time, they always record the price at the end of each block. So that in between a block, it doesn't matter what the price is, only at the end, and then that means that you can't use any flash loans to manipulate it. And then even better is, of course, if you don't just use the price at the end of one block, but you take this average over like 30 blocks or something like that, or 30 minutes worth of blocks. And then what that gives you is that because you have to keep the price manipulated at the end of the block, then there's going to be an arbitrage opportunity at the beginning of the next block, right? Because the Uniswap price is going to be wrong, and then whoever is the fastest can come and push that price down to where it's supposed to be, and then they're going to make a big arbitrage profit, and if you're the attacker, then that's a loss for you. And so that's the idea of why the Uniswap oracle is supposed to be expensive to manipulate. But now we'll get back to the future block MEV and how we can avoid this cost if we're an attacker. So what we're going to do is we're going to wait until we just randomly get a block that we're going to propose, right? So we're going to run some number of Ethereum validators, which you can do. You know, you need 32 ETH for each one, but there's not really a cost to it aside from the capital cost. But you know, there's people that do this just to stake, so it's not anything super crazy. So you just run a couple validators, and then because of what I talked about before with how the block production works, you will know exactly when you're going to be proposing a block, right? So you can know up to 12 minutes ahead of time, oh, okay, I'm going to be up. Now I can do some funky stuff, right? And so what we're going to be doing is we wait until the block we're proposing is going to be the next block. And then in the current block, what we're going to do is we're going to do a Uniswap price manipulation, right? So I have that here on the chart. We're in block N right now. And then we're going to push the Uniswap price up to, you know, some really high amount, however much money we have to push up the price, because we're basically going to be getting all this money back. So we push up the price. Then at the end of the block, the price is going to be recorded. And then the next block is going to be our block, right? So we can decide the block ordering. So we just put ourself as the first transaction in the next block, and we make sure that we are the ones that can get the arbitrage, right? And so then we can get to push the price back down on Uniswap, and nobody else has any chance of competing with us on that arbitrage because we're going to be the ones that are ordering the blocks, right? Now, one important caveat is that what could have happened is that we get backrun on our first transaction, right? Like if we're not the last transaction in the block, that might be a problem. But there's an easy solution to that, and it's called flashbots, right? If you submit a transaction through the flashbots RPC, then they claim at least that your transaction won't be visible to anyone else, right? So as long as you trust that flashbots doesn't leak your transaction, then the first block, you just submit it through flashbots, nobody's going to see it in the mempool, and the first time that people can see the arbitrage opportunity is going to be when the block is already done, and then the next block is going to be yours, so they have no chance of competing. And so if you do this, then you've created one outlier in the average that Uniswap uses for its oracle. And you've done this with a cost that is basically just whatever the Uniswap transaction fees are, right? So you might pay like 0.3% on the way up and then 0.3% on the way down on however big your manipulation is, but that's it. And usually if you weren't doing this, then someone else would arb you and you would lose, you know, a large percentage from that. So essentially what you're doing is you're hiding the MEV from the other searchers that are out there. And if this is a Uniswap v2 oracle, then this is kind of already enough. So on the Uniswap v2 oracle, the way that they do their average is just a normal arithmetic mean. So you just sum up all the prices and then you divide by the number of blocks. So if you just have one outlier that's really high, then you know you've already like manipulated the entire average. Like if it's an average over 150 blocks, and here you just push up the price by 150 times, then the entire average is still going to be 2 instead of 1, right? And that's enough to steal from a lending market. Now, luckily, kind of by chance, in Uniswap v3, they changed this, and not for this reason, like for other reasons. But in Uniswap v3, they changed from an arithmetic mean to a geometric mean. And so in a geometric mean, what you do is you multiply all the values together, and then afterwards you take a root, where it's the nth root with however many blocks you have. And so that might sound a bit fancy, but really what it means is that in this calculation, if you have one large amount in your calculation that's in the multiply, because you take the root afterwards, it doesn't have such a big impact. So if you have single outliers in a geometric mean, then that has a lot less of an effect than in the arithmetic mean. So if you're attacking Uniswap v3, you would have to repeat this attack multiple times within the TWAP window so that you can create multiple outliers. And if you can do that, then you can also manipulate it. But that means that you need to have a lot more validators, right? Like if for the Uniswap v2 case, if you just need one block, it's enough to have one validator and you'll get a block like every 1 or 2 months. But if you want to have like multiple blocks within one TWAP window, which is like 30 minutes, you need more, right? But if you have like a couple $1 million that you're willing to stake and then unstake the next day, or whenever you get through the queue, you know, it's still fairly simple to do. So if you could potentially steal like many millions of dollars, you know, you might want to do that. And now, so now we've manipulated our oracle, right? And so either we manipulate the price up, and then we can just steal from a lending protocol. But if it's a v3 oracle, that's kind of hard to do. So what might be a lot easier is if we try to manipulate the price down, right? Because if we manipulate up, we need to change it by like 100% or so. But if there are some positions on the lending protocol that are close to liquidation, we might be able to just manipulate the price down a little bit, and then we can go liquidate all those people, right? They might be away, like 2% away from liquidation, and then we just push the price down a little bit, and then we can liquidate them. And the cool part about that is we can trigger that liquidation with no competition, right? because the block in which the updated price is going to be there for the liquidations also happens to be the block that we control, right? So at first in the block, we put our arbitrage to get back all the money we spent on the manipulation. And then afterwards, we can trigger the liquidation on that protocol and any other protocols that use this oracle. And nobody else is going to be able to compete with us, so we can liquidate it super, without having to pay a lot if that's how the liquidation engine works, right? It depends. If the liquidations are over time, then it doesn't work. But if you can instantly liquidate an under-collateralized position, then you can liquidate it without any competition. And so this is basically the reason why nobody uses the Uniswap Oracle anymore. Euler actually used to use Uniswap v3 oracles, and they did a lot of research on why they think it's secure. But that was in proof of work, right? And then when the merge came close, I talked to them about this kind of stuff. And after that, they weren't so happy about it anymore. So they changed to Chainlink, which unfortunately is kind of the best solution we have right now. Like, it has a lot of centralization problems. There's one 4 of 9 multisig where Chainlink can just upgrade all of its contracts and rug all of DeFi, basically. So probably not the best long-term solution, but for the moment, it's the best thing we have. So yeah, this was the Oracle part. But then maybe there's other things that we can do as well, right? If we use this future block MEV with the knowledge of knowing when we're going to be proposing a block. And one fun thing that you can do is you just create your own MEV, right? So if you know that you're going to have a specific block, or maybe you're a big staker and you know that by chance you're going to have like 10 blocks in a row or something like that, right? You're just going to have more than your average number of blocks. You can try to create a lot of MEV in those blocks, right? So one thing you could imagine is that you could work together with an NFT project and just have them launch their mint exactly in the blocks that you control, and then you're going to get the MEV that gets created there, and you'll get paid for it, right? So as an example of that, this right here is a chart of the gas prices during the other side NFT sale, which was the Bored Ape land sale. This was the biggest NFT sale that ever happened. And you'll see on the chart at 1 o'clock, that's when the sale started, right? And you see the gas price just spiking up immediately. And the height of that is 200 ETH per block, right? So every 12 seconds, people were paying $500,000 in gas to the validators that were proposing those blocks. And the very tricky part about this is since EIP 1559, we have the base fee and the tip, right? And the base fee is the ETH that gets burned, and then the tip goes to the validators. So the tip here is in black, and the base fee is in red. So you'll see that at the very beginning, the tips were insanely huge, right? And the validators were getting all of that money. But then just after like 10 minutes or so, the tips were basically zero, and it was all base fee because the base fee just shot up so quickly. So it was super important to be in those first couple minutes of validators, because afterwards, even if you proposed a block that had super high gas, you weren't getting any of that, right? You were just burning the gas. So this shows like how important it is to be at exactly the right spot. And if you are someone that has a lot of validators, you could maybe try to influence when this NFT project launches, right? They might not care so much if they launch a couple blocks earlier or later, and then you could make a lot of profit. You could pay the NFT project for that, right? It's like kind of reverse MEV. The validators pay you to launch your project whenever they say. So yeah, I think that's a really cool application. And then the other one, which is a bit more concerning, and this is something that I talked about with a guy named Iridian, actually last week at ETH Denver. And I had never really thought about this in this way, but it's that you might actually be able to do profitable censorship, right? So incentivized censorship. And the reason for that is that in EIP 1559, as we talked about before, the base fee might be super high, but the tips that are being paid to the validators might be low, right? So I have here an example of a specific block, right, where the proposer got paid like $30 worth of ETH, but the transaction fees that were in the block were like $800, right? So it's about 1/30th of the entire fees actually go to the validator. And so what that means is that the block space is expensive, but the blocks themselves are really cheap, right? So if you imagine that you're a builder in the MEV boost system that basically all the validators use these days, what you can do is you could actually propose a block that's totally empty. It doesn't have any transactions, except you pay the validator, you know, slightly more than all the other builders, right? Like in this case, if you had paid $35, you could have gotten that block and put anything in it, right? And the validator doesn't care how much gas the block uses, right? They only care about how much they're getting paid. Like in fact, in MEV Boost, they don't even know what transactions are in the block or how much gas is used. They only know how much you're willing to pay them for it. And so you could create like blocks that are empty or that censor specific transactions that you want to delay by one block for a really low price, right, on average. Now, maybe the gas would have spiked, right, and then you would just not do it. So if it becomes too expensive, you can just not do it, and if it's cheap, you do it. And so the question is, why? Why would you do this, right? And so the answer is you censor the block before yours, right? So you know which block you're going to be proposing, and then whatever the block is before that, you just try to censor it, right? You could try to censor all transactions, or it'll actually be cheaper if you just censor specific transactions, because then you don't have to pay the entire tip to the validator. And so one reason why you would want to do this is maybe because of arbitrage, right? So there's a lot of what is called stat arb between centralized and decentralized exchanges. And the way that it usually works is that an on-chain exchange like Uniswap lags behind off-chain exchanges like Binance by 12 seconds, right? Because Ethereum produces a block every 12 seconds. So the Uniswap markets can't move more often than that. And so Binance has price discovery all the time. And if the Binance price moves in those 12 seconds, then there's always going to be an arbitrage between Binance and all the on-chain markets. And so that's going to be some amount of arbitrage. But now the kind of fun thing is that if you just censor the block before yours and you remove, let's say, all the Uniswap transactions, or even just all the Uniswap transactions of like specific pools, that'll be super cheap. And it'll make it so that now Uniswap lags behind Binance by 24 seconds, right? Or you could even try to censor it for multiple blocks. That's, you know, a bit harder in case you might not censor a later transaction. But still, you'll be able to make it so that the difference between Uniswap and Binance just grows more and more because the Uniswap markets are literally just frozen in time. And so what you can then do is either you arbitrage yourself, but you probably don't want to do that, right? Like there's already people that do the stat arb. So really what you do is you just wait until they pay you in your block to do this MEV, right? And there's a guy on Twitter, I put his handle here. He did some theoretical calculations that if you can lag the price more compared to the centralized exchanges, then if you do stat arb every 2 blocks instead of every 1 block, that should be on average 35% more profitable than if you did it every block. And the thing is, for you as a validator, the cost is going to be very low, right? So you're going to censor all the transactions that are in Uniswap in the block before, but then in your block, they're going to pay you that amount back, right? So you're only going to have to drop like whatever the bottom transactions in your block would have been, and you'll be getting these high-paying transactions that you had to pay for before. So you might not even be paying 100% of the cost of the block before yours, but then in your block, it'll probably be worth twice as much because you just have more orders, but then also because the arbitrage opportunities are bigger, and there's probably going to be multiple people that all want to take the same arbitrage opportunity, you'll probably end up making more than twice as much in validator fees and tips by doing this censorship in this way. And the other thing is that even if you ignore the centralized exchange arbitrage, even if you're just doing atomic on-chain arbitrage, you could still be making more money if you do this. And the reason is that, so one form of MEV are these sandwich trades, right, where you buy before someone else, and then they buy, and then you sell back to the pool, and this is profitable. And now if in the block before yours, there was no transactions, there's going to be twice as many transactions in the current block, right? So there's a higher chance that there's going to be 2 transactions or more that are all trying to do the same trade. And so then you can actually sandwich all of those trades at once, and that'll be more profitable, right? Because the price impact of those trades together is going to be higher, and your gas cost is still going to be the same as if you were just sandwiching one trade. So this also makes atomic arb, more profitable. And I think this is something that I hadn't thought about before last week. So a big shout out to Iridian who talked to me about this, and I found it super interesting. And yeah, we'll see. As far as I know, this isn't happening on chain right now, but there's really no reason for it because all you need is like a single validator, and then you need to be a builder in the Flashbot's MEV boost system, but that's permissionless, so anyone could be doing this, and there's even like open source versions of the Flashbots builder that you can just plug in and it'll work, and you'll make small adjustments to it. So I think this is really interesting. It might be happening and we don't know about it. It also should be actually pretty easy to see if these theoretical results of it being profitable are true. If you just do an analysis of blocks that are just naturally skipped, right? Every now and then a validator skips a block. And if you then check like how much the blocks after it are worth, I haven't done this analysis yet, but I think it would be super interesting to do. And then you could see if these theoretical results for why it should in theory be profitable actually hold up based on that data. And then, yeah, I mean, I wouldn't advocate for doing this live, but you know, it might be profitable and the incentive is there. So that's how these permissionless systems work. So yeah, that brings me towards the end. I think the big takeaways that I wanted for today is just, first of all, the block proposers in PoS are known in advance, right? This is very different than it used to be on proof of work. So the merge kind of has an impact on the block production. And then that also has impact on the applications that are running that rely on that block production, right? Such as arbitrage assumptions. And then the second thing is this information is valuable, right? So there's many ways that you can use it. I'm learning about new ones all the time. There's the simple Oracle manipulation where you could try to steal some money or liquidate people. You could try to create MEV in your blocks. You could try to censor the blocks before you and then get that MEV for yourself. You could also, of course, sell your block ahead of time, right? This is the idea of a block space future where people could pay you for your block ahead of time, and then you just guarantee them that they can have the first couple transactions in your block, and they pay whatever they think is fair for that, right? So if such a block space futures market would exist, then you could do all of these things without even needing to be a validator yourself, right? You just need to have some validators that you trust that if you pay them for the future block, they'll actually give you that block space. So yeah, I also have a blog post on chainsecurity.com about the Oracle manipulation part and you know, how the proof of stake block production works. If you want to read more, you're happy, you can read that. This is actually based on an entire paper that I wrote about Oracle manipulation of the Uniswap v2 Oracle. The paper is also linked in there if you want to go really deep. And yeah, thank you very much. I've been Torgin. If you like, you can follow me on Twitter. I usually tweet about like security, MEV, that kind of stuff. And then also actually in case you're interested at Chain Security, we're hiring a marketing and sales manager. So if you're interested in the security space and then also maybe have like a network in the crypto space, we would be happy to talk to you. Thank you very much.